So we now want to turn our attention to rational functions. So the word rational in a mathematical context usually refers to something where there's a fraction. Okay, so we have the root word, the ratio, right, implying that there's some kind of fraction going on. So a rational number would be a number that can be written as a fraction, for example. So no difference with the functions or the irrational expressions, stuff like that. That means that we essentially we're going to have some kind of function where f of x is equal to p of x over q of x, where p is a polynomial and q is a polynomial. Okay, so we'll get into the functions in a little while. First, we'll focus our attention just on rational expressions and how to handle these, right? We want to actually just look at them outside of the function context first. So let's first take a look at simplifying rational expressions. Okay, so we've already seen some kinds of rational expressions when we've looked at things like domain, right? Because these are functions or expressions where you're going to start to have some domain issues because you have that denominator, right? So that we have to make sure that the denominator can't be 0. So let's just start with an example of how we would simplify a rational expression. Okay, so here we have a quadratic divided by a quadratic. X squared plus 8x plus 16 divided by x squared plus 11x plus 28. So one of the common things that we'll do here is we'll try to factor the top and the bottom and then see if they have any common factors, right? That would be one way of simplifying them, is by canceling out any kind of common factors. So in this case, if we simplify the top here, that should be x plus 4 times x plus 4. And if we simplify the bottom here, we're going to get x plus, what's that going to be, 7, x plus 4. Okay. So we see we get a common factor. If we didn't have a common factor, then there would be nothing we can do, and we would just say it's as simple as we can possibly make it. Okay, so, but here there is a common factor with the x plus 4, so we can cancel those out. And then we are left with x plus 4 over x plus 7. Okay. Now, like I said, we'll save the function talk for later, but I do want to point something out right now as we're looking at this. You know, we're using the equality sign here to say x squared plus 8x plus 16 divided by x squared plus 11x plus 28 is equal to x plus 4 over x plus 7. And that's true, as we just showed. In a function context, though, we will need to be a little bit careful, okay, because they are a little bit different in that the domain of this function is not equal to the domain of this function, right? We still can't put x equals negative 4 into this function, okay? So while we're considering them equal, they're really equal everywhere except for at that one point, because at x equals negative 4, the left hand expression, if we think of it as a function, is undefined, whereas the right hand function is defined. It's going to be 0. So that's just something we just want to keep in our back pocket for later. It doesn't make any difference outside of the function context, which is what, not what we're looking at right now. Okay, so let's look at another one here. I got x squared minus 9 over x squared plus 4x plus 3. Okay, so if we factor the top, we're going to get x plus 3, x minus 3. This is the difference of two squares. Factor the bottom, we'll get x plus 3, x plus 1. Okay. So again, we just get the x plus 3 terms canceling out here. Okay. So nothing really like too new here, just adding on, what we were doing in the factoring section to now being able to cancel out a common term. One thing I do want to point out, one thing we should always be careful of, you know, if you didn't have anything to cancel out, like if, let's say we were doing x squared plus 9 over x squared plus 4x plus 3. Okay. So in this context, there's nothing to cancel out. X squared plus 9 is not factorable. So, you know, then the only way you could cancel something out is if the bottom had an x squared plus 9 in it, which it doesn't. So oftentimes our brains will kind of trick us and be tempted to do something like cancel this out, because you see an x squared on the top and an x squared on the bottom, but they need to be multiplied by each other, right? They need to be factors in order for us to cancel them out, because we're canceling them out via division, right? The reason we can cancel x plus 3 on the top and bottom here is because x plus 3 divided by x plus 3 is equal to 1. So this is 1 times this thing, which is just going to be this thing, x minus 3 over x plus 1, right? So canceling out is really division. Here, these are being added and these are being added. So we're not able to just divide those terms, okay? And it's really easy to see with numbers. If you have something like 1 plus 3 divided by 4 plus 3, well, this is going to be equal to 4 over 7. Okay. If you were to cancel them out, then you'd have this equals to 1/4. And we clearly know this isn't true, right? 4/7 is way larger than 1/4. Okay, so we can easily see with numbers that it's not true. But sometimes when we're working with the abstract over here, our brain will just focus in on those x squareds and just immediately want to cancel them out. So just something we want to avoid here. Okay, so one more example here. Let's say we have x minus 6 over x squared minus 36. Okay. So in this case, the top, we can't factor any further. It's already just one factor. The bottom is going to be x minus 6, x plus 6, because it's the difference of two squares. And now these cancel out. So another thing to note here, when everything cancels out on either the top or the bottom, what you're left with is 1. Because what you're really saying is that, if we kind of just break down exactly what we're doing here, we're really saying that this is equal to x minus 6 over x minus 6 times 1 over x plus 6, and that this is 1, x minus 6 divided by x minus 6. So sometimes some people like to just write a 1 over it instead of just putting a slash through it, right, to actually signify that that's equal to 1. So this is equal to 1 over x plus 6. So sometimes we're tempted to put like a 0 up here or something because it's gone, right? So there's nothing there, so it's 0, but that's not going to work because that makes the whole thing 0. So we're really doing division, so we're left over with a 1 on the top.